All right, so I want to go ahead and do a video to go over the study guide with you, and mainly I'm going over just the answers on the study guide and how you would find them. I'm not going to go into a lot of detail with it because I've already posted video on YouTube for all of this stuff that tells you how to find all these answers. But just to go over what the answers should be and what your thought process should be on this, I figured I'd go ahead and make a quick video. Well, it might be quick, we'll see. So it says ABCD is a rectangle, so this quadrilateral we're dealing with is a rectangle. It says if AC is 52 degrees, what is the measure of BE? So real quick, all parallelograms, the diagonals do bisect each other when you have a rectangle involved. So that would cover a rectangle or a square because they're both rectangles. Those diagonals are also congruent to each other. So if AC is 52, then BD is also 52 because the diagonals are congruent. So then also the diagonals bisect each other, which means cut in half. So half of BD would be what we're looking for because it says BE. 52 divided by 2 would be 26. So the answer should have been 26. And you can see right there I've got correct answer, 26. So we're doing the same rectangle here. Now it says ECD is 55 degrees. What is the measure of ABE? So this angle. So this angle, ECD, is 55 degrees. This angle, ABE, it's going to be the same. It's 55 degrees. Just like I told you in the video before, rectangles, when we use our diagonals, you're basically chopping it up into 4 isosceles triangles. This triangle being congruent to that triangle, and this triangle being congruent to this triangle. And I go into more detail on that on our video with rectangles. But for this, just answering this question, ECD, this angle is going to be congruent to ABE, which is that angle. And also this angle is congruent to that. This angle is congruent to that. So we have these angles are congruent to each other. And then on the other set of triangles, we have this angle and this angle congruent to this angle and this angle. So like I said, long story short, it should have been 55. Same rectangle. Now we have DEC is 70 degrees. So this angle here, shoot, didn't mean to click on it yet. This angle here is 70 degrees. Wants to know what EBC is. Let me click up here so I can see. So we're looking for EBC, which is this angle. So we have 70 degrees here. It wants to know, well, what's this angle? Sorry, I was looking at it wrong. I'm on the wrong problem. It moved. Daggone it. Sorry about that. So DEC is 70 degrees. It's looking for EBC, which is this angle. So if this is 70 degrees, this angle would be 110 because they're a linear pair, right? I could use that to figure out that these two angles add up to 70. Or I could say, well, exterior angle theorem, if this is 70, then the sum of these two angles will be 70 degrees. Now, where that helps me here is I know this is an isosceles triangle. So 70 divided by 2 will give me that this is 35 and then that's 35 because these have to be the same angle. So these angles have to be congruent and have to have a sum of 70 degrees. And that's just because of triangle sum and exterior angle theorem and all that good stuff. Because this angle is 110, then that leaves 70 degrees for these two because 180 minus 110 is 70. 70 divided by 2 gives me 35 here and 35 there. So it should have been 35 degrees. Says AC is 34. What's the measure of BD? 34. Again, we already talked about the diagonals being congruent in rectangles. So if one's 34, the other one's 34. EAD, now we have EAD, which is this angle, is 40 degrees. Wants to know what ECB is. Well, if that's 40 degrees, then ECB is also 40 degrees. Because remember, these two angles are congruent to each other along with these two angles. ABCD is a rhombus. If the measure of EAB, so if this angle is 35 degrees, what is the measure of ECD? So EAB is 35 degrees. ECD, it's also going to be 35 degrees. With a rhombus, your diagonals bisect the opposite angles. on the opposite angles by being parallelogram or congruent. So this whole angle is going to be congruent to this whole angle because they're parallelograms. And then this diagonal is going to bisect this angle here and here. And there you have it. So it'll be 35 and 35. Let's see. And that's all on your flow chart. I'm trying to think if I have the flow chart in the background somewhere. Okay, I do. I meant to have it up anyway. See, diagonals bisect the opposite angles. So it's right there under rhombus. You look at all your rhombus rules and stuff. I'll leave that up for the rest of this video. Let's see. EBC, the same rhombus here. EBC is 40 degrees. What is BCE? Well, if this is 40 degrees, then it wants to know what BCE is. The other thing we know about rhombus, diagonals are perpendicular. So these are all 90-degree angles here. These are perpendicular. So if that's 90 and this is 40 degrees, then that only leaves 50 degrees for that because it's got to add up to 180 for that triangle. So 50 degrees. Let's see, rhombus, the same rhombus here. We've got EDC now, 25 degrees. Wants to know what DAE is. So if this is 25 degrees, wants to know what DAE is. Okay, best way to do that. This is 25 degrees, so that means this angle is 25 degrees because these angles are the same. The diagonals bisect the opposite angles. So if they're both 25 degrees, I got a 25-degree angle here, 90-degree angle there. I can use triangle sum, subtracting both from 180 to get my answer, which is 65 degrees for this angle, because 65 plus 90 plus 25 equals 180. Okay, same rhombus. Now we're talking about the diagonals. It says EB is 4 degrees, or is not degrees. If it says if EB is 4 and EC is also 4, what is the measure of AD? Okay, so this is a little bit different. It was not supposed to, this is wrong. Flat out, this is wrong. What this was supposed to be, EB was supposed to be 4 and EC should have been 3. Should have been 3. And what this would have been, you would have used Pythagorean theorem to find this side. Okay. And that side would be congruent to any of the other sides. So that was supposed to be 3, 4, 5 triangle, and you should have used Pythagorean theorem. Because I put that wrong one there, it may or may not show up on the study guide, or not on the study guide, on the test. We'll have to see. I might throw that one out just because I typed the answer in, or the question in wrong. But anyway, that should have been this side was 3, this side was 4, and use Pythagorean theorem to find out that BC was 5 because it's a right triangle, and then use that's 5 to find AD, which is also 5 because all the sides of a rhombus are congruent to each other. Sorry, I got myself a little shook up there by seeing that was wrong. Threw me off a little. ABCD is a square. What is the measure of AED in degrees? So if ABCD is a square, we've got a square here. It wants to know AED in degrees. Well, square is the type of rhombus, right? So AED is 90 degrees. These are perpendicular bisectors, or perpendicular diagonals. And they do bisect each other also, but yeah, so these are all 90 degrees. Wants to know ADC in degrees. So ADC in degrees. Square is a type of rectangle, right? That's a 90-degree angle. ADC is a 90-degree angle. So we've got 90 here, 90 there. EDC now, we're looking for EDC. Well, just based on the rules of a square, doesn't matter what anything tells you is about the sides of it. All the angles are the same. So I've got 90-degree angles all the way around. I've got 90 degrees on my diagonals because they're perpendicular. Then I also have the opposite sides or opposite angles are bisected by the diagonals. And basically, long story short, I got 45-degree angles all the way around. So 45, 45, 45, 45, 45, 45, and 45, 45. EDC would be one of those 45-degree angles that's right here. So 45. ABCD is a square. If AD is 10, what's the measure of BC? If AD is 10, BC is also 10. And all those sides would be 10, obviously. ED is 4. What is the measure of AC? So ED is 4. Wants to know the measure of AC. Well, if this is 4, then the whole thing would be 8. So AC would be 8. Now we're looking at mid-segments of trapezoids. It says AB is 5, DC is 17. What is the measure of the mid-segment? You just take their average. 5 plus 17 is going to give you 22. 22 divided by 2 is going to be 11. So it should be 11 because it's the average of 5 and 17. PAB, 105 degrees. What's the measure of PDC? These are supplementary. You've got a trapezoid, PAB, that's 105 degrees. The angle that's on the same leg is going to be supplementary to that. So it should be 75 degrees. And it is at 75 degrees. These two angles don't relate to these two angles at all. They relate to each other. These are supplementary to each other. These are supplementary to each other. And I went over that more in the trapezoid video. Now we have an isosceles trapezoid. This is different. Now they do relate to each other. The base angles are congruent to each other. So this angle is congruent to that angle. This angle is congruent to that angle. But then they're still supplementary on the legs. So A and D supplementary and B and C supplementary. It says ADC is 35 degrees. What is BCD? Okay, if it's 35, then BCD is 35 because they're congruent to each other. ADC, still the same trapezoid, isosceles, right? ADC is 35 degrees. What is the measure of ABC? Okay, well, if ADC is 35 and it's supplementary to DAB, or this angle here, so if this angle is supplementary to that angle, then you do 180 minus 35, and it'll give you 145 degrees. Where that helps us is this being congruent, because it's isosceles is the only reason. These are congruent to each other, so if this is 145 degrees, so is this angle, which is what we're looking for, ABC, 145 degrees. We got an isosceles trapezoid still. It says AC is 12, BE is 3. Wants to know the measure of ED. All right, so the diagonals are congruent to each other, but they don't bisect each other. So if they're congruent to each other, the whole thing's 12. So that means this whole B to D is 12. So if I go 3 here, 12 minus 3 gives me the ED would be 9. So that would be your answer there. Isosceles trapezoids still. BA is 7. Wants to know CD. It's the same. Isosceles trapezoids, the legs are congruent to each other. So BA and CD would be congruent to each other. Be 7. Now we're done with kite. Says we got a kite here. OM is 5. What's the value of OH? 5. This is a line of symmetry across this kite. Anything up here is the same as the mirror image down there. So OM and OH are congruent. It's also 5. ME is 9. What is HE? Well, if ME is 9, HE is 9. Two easy ones right there together. 9 and 9. That's the same distance. Measure of HRE, 90 degrees. These are perpendicular diagonals. Should be 90 degrees. All these angles are 90 degrees. RMO is 50 degrees. What is the measure of RH or ROH? ROH is down here. What you would do here, this is the 90-degree angle. So basically, kites are broke up into 4 right triangles. If RMO is 50, then that tells me that I can use triangle sum to say 180 minus 90 minus 50 will give me that this angle, which is ROM, would be 40 degrees. Well, if this angle is 40 degrees, then this angle is 40, which is what we're looking for, ROH. That would be 40 degrees because this is a mirror image here. Whatever this triangle is, this is the same thing, just flipped over. So 90, 50 and 40, and then here would be 90 degrees, 50 degrees, and 40 degrees. It just flips down. So it should be 40 degrees. And then last one here says we got the kite, RMO is 50 degrees. Then it also says OHE is 120 degrees. So this is 120 degrees, this whole angle here. And wants to know REH. So we got to think a little bit about this. If this whole angle's 120 degrees, but this angle's 50, well, this angle's 50 as well. So what that does, it allows us to find out what just this part is, because this whole angle's 120. Well, this part of it's 50. 120 minus 50 leaves 70 degrees for this angle, which is RHE. So this angle is 70 degrees. The reason that helps us, if that's 90 and that's 70, then that only leaves 20 degrees for the angle we're looking for, REH. So it's 90 degree angle here, 70 degree angle there, and that gives me 20 degrees for this angle, which is my answer, 20 degrees. Y'all, look, most of this, I mean, pretty much all this you're going to have on your test. The only exception, I might take off the one where you had to use that this was the right triangle, and I had, let's see, which one is it? I gotta find, okay, right here, and I had 4 and 4. It's supposed to be 3 and 4. You know, whatever. I'm not gonna worry too much about that. I just mainly want to make sure that you understand that's how you would have done it. You would have used Pythagorean theorem. If I do include that on the test, that type of problem, don't let it throw you off. I'll even put in parentheses over here with it. I'll say, hint, use Pythagorean theorem to find the value, okay? But I don't know. We'll see. I might throw that in. I might not. Be ready for all of it. Study this flow chart. Study your parallelograms. Let's see, get the whole flow chart here. You need to look at all this, understand all the rules of it. You can use this flow chart on your test to reference. You know, it's probably a good idea. You're going to have questions that the answers come straight from this. If you get those questions wrong, that's on you, because you've got this at your disposal. If you need me, I'll be on Google Meet during class time. You will have your test tomorrow, Wednesday. So be ready for it. You'll have this stuff, parallelogram stuff, and then you'll have just basic questions about all of them for classification purposes. Classifying means to say, like, I'll show you a shape, or I'll give you rules about a shape. You tell me which shape I'm talking about. It's that simple. All that stuff can be brought out right here.